Hi everyone. The purpose of this video is to give you some background and terminology into analyzing data so that when you get to class you can hit the ground running and start to use some of this terminology in understanding the data that you've gathered from your own research project. So what we'll cover today is talk just briefly about common myths about data analysis, why we do data analysis, and then some terminology such as what is a variable in data, different scales of measurement and methods of calculation, and then you'll have a chance to begin your data analysis. Some common myths around reporting on data is that analysis has to be complex. But in reality, most people, even researchers that are studying in their area of expertise, appreciate plain language explanation. So we want to break it down. We want to take this data and we want to make sense of it for people. We want to make it as clear as possible what the findings are, because without it then we don't have any confidence, or people don't have any confidence in the data that you've found and what the meaning is behind that data. Also, we have thought about analysis all the way along. We do the analysis part at the end when we have our data that we can use that can prove something, but all the way from starting your research question, you already had some assumptions about what you wanted to gather and what you wanted to analyze and what you might discover, and that comes into play in the development of your survey questions, your objectives, and your research question. And remember that numbers and words can be equally important in analysis, but it's the quality of analysis that is important. So it's the process of how you look at that data that gives it validity, that gives your research study validity and reliability. It's not just because you can represent something by saying, 95% of this. That isn't always the end game, because sometimes we want to use a description to describe certain things that are found, and that's equally as credible. Also, data must always be interpretive. Numbers do not speak for themselves. So if you discover, for example, that 95 of your participants agreed that working part-time while they're in school takes away from study time, that in itself is interesting, but it doesn't really tell us anything. There's implications in those statistics in terms of student achievement and performance, right? That many students that are working part-time, it's got to impact their performance at school. There might be time management issues, etc. So there's an interpretation that goes after you discover the data and can make certain claims about the data, then there's an interpretation that goes along with it. And remember that all analysis have weaknesses, and the most important thing is to be honest in reporting them after the fact. You might discover when you have your survey results in that you wish you would have worded a question differently, that you would have found out something more interesting or something more accurate if you would have asked it in a different way, and that's okay. If you've discovered that, then just report on it, and it becomes part of the limitations of your study, the limitations section of your study. But not reporting on it and not identifying the weaknesses makes your study less credible. And also for small data sets like yours in this project, you can tabulate the results by hand relatively efficiently. But also in SurveyMonkey, if you've used SurveyMonkey, there is a tool in there that allows you to do some comparison between questions. So let's say that you have a question related to the age of your participants, and then you can look to see how certain age categories responded to different questions. So in all cases, interpretation of the data is the process of attaching meaning. So it's so important that there's an interpretive part of the data, not just reporting on, but also telling us what that data means. At the end of your study, you'll be writing a conclusion and recommendation section, and in that conclusion, you'll be talking about what you learned, and are there any aha moments? Is there anything new or unexpected in the data that you gathered? And that's where it becomes interesting, if there's anything that surprised you, and then you can also identify if there's areas where further study might be necessary. You'll hear some terminology here that comes from statistics. So if you've taken any statistics courses, you'll recognize some of the terms that we're going to be using. But doing data analysis and doing research is a scientific investigation. And what we are trying to do is discover relationships among phenomena. And that will help us to explain and predict and possibly control their occurrence. This is why we do this investigation. So statistics uses variables. And for example, if you were doing a study on the health of a cat, you might have two variables. One might be whether they are indoor or outdoor cats, and another might be what they're fed. So there's the power of the data comes from doing a comparison of that data or finding a relationship. If I go back to the previous slide, we're looking at what a relationship between phenomena. So there might be a relationship between whether a cat is indoors and the fact that they have a high fat, high calorie food, and that then they might be more obese. That's not rocket science, but if you do a data study and discover that, then you've got some credibility behind your claims. Another example might be what learning strategy works best for a student in the classroom. And there might be several variables, oral learning, visual learning, kinesthetic learning, different ways that people learn. And so those variables might affect how well the student performs in that particular class. There might be other variables like the type of class that it is, and that a particular learning strategy might work better or might be identified as working better in a particular type of classroom or a particular area of study. Here's an exercise then for you. Let's say a local city wants to know how long people are waiting at a stoplight. And if it's at the LRT stoplights, it's a long time in Edmonton. But they send out monitors to 20 intersections to measure the wait times at stoplights at different times of day. So what would be the sample in this case? So the sample are the things that are going to be observed or questioned, and that would be the 20 intersections. So what would our population be? So if our sample is 20 intersections, our population would be all the intersections in the city. They've selected 20. So what would our variables be that are involved? So the variables then that we're measuring, the things that we're measuring would be the wait times. So the time interval that people wait and the time of day that these different wait times occur. So there's two variables in that case. When we're talking about analyzing data then, and think about your own study, and your own study will encompass several of these. It doesn't just do one thing. It might be doing several things depending on which of your data that you're investigating. So this helps us to make sense of our data and to put it into the context of our question. So if we are describing and summarizing data, this is probably not what you guys, or none of you, are going to be doing. You might do a little bit of it, but so this might be a study that, if we take the example of orientation and training programs for restaurant employees, a study that describes the methods that different restaurants use and different methods of orientation at restaurants of new employees, and the report summarizes the methods. That would be a describe and summarize, and the purpose of that would be so that different restaurants can learn from each other on what other restaurants are doing. Your study might identify relationships between variables. So let's say that if we want to study the effectiveness of an orientation program, there might be a relationship between one variable, which is the length of the orientation program, and another variable, which might be the length of time an employee stays at the company. So we might discover a relationship where a longer orientation program might lead to an employee staying longer in the company. So that's a relationship. You might compare variables. So maybe you'd compare orientation activity number 1, let's say it's observation, with orientation activity number 2. Let's say the employee studies the manual. And you might compare whether orientation activity number 1 is more effective in employee retention than orientation activity number 2. You might study the difference between variables. So you might have, say, a gender question, male, female, and those would be variables. And you might look at what is the difference between male employee retention rate and female employee retention rate. Or age, let's say those employees who are under the age of 25 and their retention rate with those employees who are over the age of 25 and their retention rate. You also might be forecasting an outcome. So this is used, say, in weather patterns, storm patterns, right? Where weather people forecast the likelihood, I guess they're called meteorologists, forecast the likelihood of a hurricane, let's say, in a particular month. So can we forecast, in this case, the length of retention of an employee based on their orientation experiences? Maybe we can. We can forecast the outcome of how long they're going to stay in the company based on what their experiences, what they've experienced with orientations. Scales of measurement is some other terminology that you'll need to know. And in your textbook, this is covered on page 180 on figure 7.1. And we're just going to talk about quantitative data today, not qualitative. But different types of quantitative data that will come from your study will either be categorical or numerical. So categorical is usually when it's described by words, and numbers is obviously when it's described by numbers. And different types of categories are nominal categories and ordinal, and we'll talk about that in a second. And then there's 2 different types of numerical categories, discrete and continuous. So numbers that can be measured and numbers that can be counted. So with nominal, if I just go back to this, we're looking at categorical now. There's nominal categories are ones where there is no obvious rank order. For example, it might be in which faculty are you studying? So there's no rank to that. There's no like one's number 1, one's number 2. It's just it's categorical data. And so the reason that we're thinking about this and talking about this is because this comes into play when you're deciding how you're going to visually represent your data. So if you don't have any obvious rank order, you're going to do it in a different way than you would if you had data that had a ranking. You would show it in a different way visually. So this type of categorical data might be best represented in a pie chart, right? Where it will show sort of the proportion that people answered in each of these categories, but there's no obvious rank. There's no one better than the other. An ordinal then is when there is an inherent order that exists. So any of your ranked questions that you used or any of your Likert scale questions that you used are called ordinal data. And so then that would be represented in a different way. It wouldn't be best represented in a pie chart. It might be best represented in something a little bit different, like a bar graph, where it kind of shows the range, the different ranges or the different orders. So that's categorical data. Then when we're talking about numerical data, it can either be what's called discrete data or continuous, and you've probably heard of this if you have taken statistics classes. So discrete data can be, the best way that I remember it is discrete data can be counted and continuous is measured. So for example, on how many days did you visit the library last week? That can be counted. There's only 7 days in a week that you can choose from. But how much time did you spend studying last week is measured. So it can be a continuum between 1 to 7 days or however many hours or minutes that there are in that time period. You could say you studied for 1 hour, but it might, it's not ever exactly that. It could be 1.0001 is what you studied. So when it can be measured, then it's called continuous. If you want a video that clarifies this a bit better, you can look at this link that talks about measured and counted or discrete data. So as a little exercise then, is, if you're counting the days late for work last month, is that discrete or continuous? Since I said the word counting, then you know that it is discrete. Rainfall levels. So rainfall levels can be measured, so that is a continuous. It's on a continuum, it's on a limitless scale. Total cost of purchase made at a store. So that will be discrete because you can only purchase, within the currencies that we have. Patient temperatures at a hospital, say. So that would be continuous because, again, it can be measured. And if you want to have a yet additional video to clarify, you can look at this video that talks about qualitative and quantitative variables and discrete and continuous variables. So then the question becomes, when you determine if you've got categorical data or numerical data, and whether that numerical data is discrete or continuous, you can pick different methods of visually representing this data. So hopefully this chart will help you in picking out how you want to represent your data on your research project. And this is also covered in your textbook on page 185. And then it gives different examples of what a table looks like, what a bar graph looks like, histogram, etc. Now, I'm sure that those terms are familiar to you and you know what they look like, but you may not have thought about why those different visual graphs have been used and why they have been chosen as being the best visual representation of a particular piece of information. So this will help you to determine what you want to use that makes the most sense for the type of data that you've gathered. And I suspect you will be using more than one because you probably have categorical and numerical data that you want to represent, so it will be represented in different ways. You don't have to get super fancy. You don't have to, we have to use all 6. You use what is logical and makes the most sense. So in class, we're going to be looking at your initial survey results, or I'll give you an example that you can work with, that you can determine the best method of analysis or what it is you want to discover. You can think about how you might best visually represent that data, and then just come up with 3 analyses that you can draw from your data. So 3 sentences or conclusions that you can come up with from studying those variables and doing those comparisons or checking those differences, and then write that down and hand it in at the end of class. That's what we'll be doing. And there's more information on this slide as well, and also in chapter 7. So thanks so much for listening to this, and we'll see you in class.